Bismillahirrahmanirrahim. Assalamu alaikum and good morning to my students, especially the student who asked for it. Well, you asked for it for exercise 7.7.7.5 today. So I'm going to solve this exercise in front of you, and it is a very small exercise with 5 or 6 questions, and the book is this one. Third edition. Cambridge IGCSE Mathematics Core and Extended Course Notebook, Karen Morrison and Nick Henshaw, third edition. So I have already done this exercise in second edition, but now in third edition. Where does it? Where is it? Here it is. Okay, now let me start. Now there's a word let for it. Let. You see, if I have a cube, now this is a cube, may not be symmetrical, but it is a cube. And it is made out of the cardboard. It is made out of the cardboard. And if I want to open the sides of the cardboard, what will happen? You see that it has 6 equal sides. 3 are in the front and 3 are at the rear, which are not visible to you. Now this sort of figure is called 3-dimensional figure because there are 3 dimensions visible in this diagram. How? You see that this is the length or breadth because it is a cube, so length and breadth and height are same in this specific figure. So this is length, this is breadth, and this is height. Since all are equal, so no matter that what it is length, what is breadth, and what is the height. My dear, now if I open it, for example, just imagine that this is, now this sort of thing is a cuboid, which I am going to show you. I'll show you cube as well. Let me show you cube first. Then I'll show you cuboid. See, this is a box. Now this is a, where are you going? You see, this is a box, Logitech. It is a headphone. It is a precision flying stick. I'm not concerned with the contents what are in this box, but I am concerned with what is this box. This box is a cube. Now if I open the flaps of this cube, what will happen? You see that this flap has been opened. You see this one. There are 6 such flaps. 6 such flaps in this box. 1, 2, 3, 4, 5, and 6. If I open these flaps, what will happen? What I am going to see if I open this flap? I am going to see a 2-dimensional figure out of 3-dimensional figure. A 2-dimensional figure out of 3-dimensional figure. Okay, I was going to show you cuboid as well. So this book is a cuboid. And if you open the side, you will get again the 6 faces, but the length, breadth, and the height are different. You see, this is one flap. This is the other flap, which you can pull it 3, 4, 5, 6. Okay, so these are the 6 flaps for cuboid and cube. And if I open these, what will happen? We'll be seeing a two-dimensional figure out of it. We'll be seeing two-dimensional figure out of it, and that will be like this. Now one face is this. We can fold it from the dotted line. Now my dear student, the figure, this three-dimensional figure has been opened up into two-dimensional figure. You see, I've already made 4 faces. 1, 2, 3, 4. And rest of 2 faces are there. 3, 4. 1, 2, 3, 4, 5 and 6. Now this, if you fold, keep on folding it from the crease, from this dotted line, it will again become in three-dimensional figure, and which is a cube. And if you open a cuboid, which I told you just now, the simple difference between them, this and this, will be the simple difference between cube and cuboid will be the difference between length, breadth and height. In this special figure, which is a cube, now this is a cube. In this figure, in this very figure, all the 3 dimensions are equal. If I say S, it will be S, it will be S. Okay? But in cuboid, now I've shown you the book. The cuboid is like this. Okay? Now this is a cuboid. Height is, you see, thickness. You can say it is a thickness. Thickness. This is length. And this is breadth. This is breadth. And if you open it, it will be opened with the same format, as it is, because it has also 6 faces. Now just suppose that this is the face which is at the top. Now this is the top face. The top face will be appear like this. Okay. This is the second face, which is like this one. So this is the thickness. And third face will be again like this. Now let me mark them. This is the dotted line from which I am going to fold. Now you see that first face is over here, second face is over here, and the third face on the base is here. So we are left with 3 bases now, 3 faces now. Now the third face, the fourth face is like this, shorter one. Because height will remain the same, it will become the breadth. Okay? And similarly, we will be extending this to this, and this. Okay, now you see, for cuboid I have drawn this figure, maybe not symmetrical because this slips too much on the whiteboard. Okay, now these are the one. Now you see that there are two rectangular faces only, two large rectangular faces. One is over here. You see, this is also a cuboid. This is I have purchased to draw figures for you. So this is one large rectangular face. One large rectangular face. Now, what I told you, one large rectangular face, one small rectangular face. Small rectangular face. Mind that this height will remain the same and the length will remain the same in this case. Okay. Now you see, this is the length. Now for this is the length for this is the breadth for this. Okay. Now for this, the length remains the same, the thickness is here t. Now this is the thickness and here it is visualized. Now I just flip it over. Now this will come. Now this is shown here. How many faces I have shown? 1, 2, 3. 1, 2, 3. Now 3 faces on the sides. One with shorter. This one is here, and this one is here, and this one is here. Okay. Now we have drawn 6 faces out of it. 1, 2, 3, 4, 5, 6. Okay. Now this is the cuboid, and we have many more 3-dimensional figures which we can convert into unfolded figures with 2 dimensions. To unfold a 3-dimensional figure into 2-dimensional figure, it is called net. Okay, it is called net. So now the exercise number 7.5 deals upon this. Well, my dear student, this is called an isometric view. Okay, in drawing, when I studied this, it was I was in 9th grade when I studied to draw the isometric view. So the isometric views are drawn with 2 angles. Okay, the isometric view. Now this is an additional information for you. It is not in your exercise. These are drawn in 2 angles with 2 angles. So this is angle 45 and the other is 30 degree. So these are called isometric view. I have drawn it almost only 45 degree, but it is, even then it is rough. So my dear students, you are seeing a figure of cuboid, an isometric view of a cuboid. Now what question has been asked to us is, the diagram shows a cuboid, draw a net for the cuboid. It is very simple. If the dimensions are given, yes, the dimensions are given in alphabetics. This is A, this is A, the height is B, and this is C. This is B and this is C. Okay, now this is correct. Now this figure I have to transfer it into net. Okay, transform it into net. Now what will happen over here? we'll take this A, C, A and C first. A and C. And what about, you see that this is, for example, this is something like 22 centimeters on board. So I draw A over here. This is A. I have to leave the space over here also for this B. Yes. Okay. And C. B is about 10 centimeters. About. Not very much accurate. I am going to transform this into a net. You see that this is A and this is B, because I have drawn this face. First I have drawn this face, the top face. Okay, now this is the top face. Now I will draw this part which is the front. It is the front, or the elevation, you can call it elevation. So this is front of the, now the front consists of two dimensions. Now these, each figure which will be transformed here will carry two dimensions. You see that this carry A and B, A and B. Now this will carry C and A. A has already been drawn. Now C is 7. Suppose it is 7. Okay, draw 7 over here. And A has already been drawn over here. Now I am going to make it a dotted line, because from here we will have to fold it. Okay, now these are the two figures which we have done. These are two. Now this is front. Top has been done, front has been done. Now the base on which the figure is lying upon, the base which is not visible to us. But if I want to visualize it, what will I do? I'll draw a dotted line over here. with the same angle, and I'll meet this over here and the height over here. Now this dotted, half dotted and half full line shows us that this is the base. Now let me do the base. Now this is the base. Now I'll draw this base. You see that again we have to cope with two dimensions. One is B and one is A. Now A is again there. I have to draw B, which was, oh yes, almost here. If you can see it on the camera, I'll just lower the camera if you won't see it. Now again this line will be dotted. Again this line will be shown dotted. You have to fold this. You have to fold it from the dotted lines. Now what comes over here? You see we have done three: the top, the front, the base. Now this side which is hidden at the left side, okay, front is always front is there, and the side which is on the right side, and the back side which is again with two dotted lines. This is the dotted line for back, and this is the dotted line for back, and this is the full line which is only visible to you. This full line is visible to you, this full line is visible to you, two dotted lines. Now I just erase this and write here back, because this is not visible to you, not even to me. Okay, now top, front and base, I write it base. Now it is visualized, now it has visualized top, front, base. Now left side, this is left side, this is right side, and this is this. Now left side contains C and B. C and B. You see, C we have already drawn over here. This is A, B, and this is C. So we'll extend this to we are going to extend this like this and close it from here. So this is B, this is C for left. Now this is the left, and just do it, dot it. I hope you are understanding. Now a long line. Now in the long line, this is just a construction line, okay? I have to, now you see we have completed 4 faces, top, front, base, left, now right, this one, the right. The dimension of the right and left are same. The dimension of right and left are same. So just mark it over here and do it like this. Tick, tick, tick. This is right, the right side. Okay, now which one is left? The back side. The back side, which is equal to the front side. Which is equal to the front side. Because in this book, you see that the front side, this is the front side, and the back side, these are equal. These are equal. So my dear student, okay, so just finish this figure and we'll finish the question. Now this will be equal to A. This will be equal to A. And this is the back side. Where you are not seeing it, now here you can see. Now we have completed all the 6 faces and we have opened this. We have opened this 3-dimensional figure into 2-dimensional figure. Now this figure is the net of this figure. Now when I was in grade 4 in 1969 maybe, I don't remember. So these workbooks were available at that time. So we have to cut it from here. But in the workbook there was also a gluing flap was made also in there to glue it from one another. This is for the gluing. This is not in the figure. This is not in. So you just fold it from here, fold it, paste some glue over here, paste some glue over here, and all these faces had a glue mark over there, and then we just join these with the help of glue, and the figure was completed. So this is the question number 1, and now the question number 2. In question number 2, a net is given to you, and you have to construct a three-dimensional figure. Now, what is it, the net? If I just keep on doing it very precisely, it will take too much time. So I am going to do it rough. This is one side, this is the other side, and this is the shorter side, and on these there are two flaps like this, and you can see this figure on your book. Now there are some names given to it. STRU, STRUR, PQ, VW, XYZ, MNO. Now there are three questions asked about this particular figure. Number 1 is the diagram shows a net of a solid. Now this is an undefined net of a solid. We describe the solid as in as much there you can see. Now you have to describe what type of solid it is. Now what will we do? You see that I am going to fold it from here, because now this is a complete line given to you, regular. I'll fold it from here, because these lines show that. Now in your book the dotted lines are not given, continuous line is given. So I have made it dotted line. So I just fold it from here, fold it from here, fold it from here, fold it from here, fold it from here. And what will happen now? You see that what kind of figure I will see here is, what I will see is a trapezium. It is a trapezium. Okay, it is a trapezium. So, and the second part B, now this is A, B. Part B says, which 2 points will join with point M? Where is the point M? Which point will join point M when this net is folded? When this net will folded, which part will be joined? Which part will be joined with M? The answer is, to draw this figure, to make it, you see I have to fold this from here. So this part is going to attach with this part. Okay, this part is going to attach with this part, and this specific point will attach this point. Okay, this specific point will attach this point. So our answer is that it will be O and S. Okay, the third question is, which edges are equal in length to PQ? Which is PQ? Where is PQ? Yes, this is PQ. PQ. Now these edges, when just watch your figure in the book. Now this PQ is equal to RQ. PQ is equal to RQ because this will be joining over here. PQ is equal to RQ. And similarly UV, W and V will be joining at UB. Now these two parts are also equal. These two parts are also equal because we have to make a symmetrical figure out of it. So PQ is equal to RQ is equal to VW is equal to UV. Okay. Which edges are equal to PQ? Okay, now all the three questions have been done. And now question number 3. Question number 3. A teacher asked her student to draw the net of cuboid cereal box. These are the diagram and these 3 students do which of them is correct. Now just see it right on the book. Right on the book. I am coming nearer to you. You see, now this is your question. Figure A, figure B and figure C. Now the question is, a teacher asks her student to draw a net of cuboid cereal box. These are the diagram the 3 student has drawn. Now I am going to draw only the correct one and give you the reason. Though she has the author has not asked for the reason. He has asked which of them is correct, but I am going to tell you the reason, which is the correct answer. Now my dear student, what I told you that when we open a cuboid, it has 6 faces in 2 dimensions. 6 faces in 2 dimensions, and only one figure out of these 3 figures shows 6 dimensions. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Okay. Now there are only 2 figures out of 3 which shows 3 faces, and I have to filter them. Now B is to rule out. We rule out the figure B out of. Now this is question number 3. We rule out the figure B completely, which is totally wrong, because in this figure you see that this is drawn like this. This is drawn like this. There is one flap over here, one flap over here, one flap over here, and one flap over here, and this and this, and this and this. So you see that there are how many faces? 1, 2, 3, 4, 5, 6, 7, 8. There are 8 faces. 1, 2, 3, 4, 5, 6, 7, 8 faces. Yes, there are 8 faces. This is the correct figure with 8 faces. 1, 2, 3, 4, 5, 6, 7, 8. But I told you how many faces? 6 faces. So the B is totally wrong. B is totally done. Just rule it out. Now, but 2 figures are left. A and C. A and C are left. Both having 6 faces. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now I have to choose. Yes, I have chosen. C has to be again ruled out. For what reason? Yes. Let me draw the C. Like this, it is same 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 like. No, here it is not. this is C. You see that it is 1, 2, 3, 4, 5, 6. Now, though there are 6 faces in the figure C, but if you fold it from here, then here, yes, from then here, now you see that this and this are repeating. This are repeating. Now this is equal to this. This side is equal to this side. So it is wrong, because when you fold, the two sides will come on the same face. These two sides will come on the same face. For example, if this is front, now this is also front and this is also front. So this is also this has been also ruled out. Now only the left figure is A, which is like this. And like this. Okay, you see that only one fold is showing in each. So if I fold it from here, this will be folded like this. Fold from here, this will be folded. Then this will come. Now this fold has been folded at 90° with this. This fold has been 90° with this. This fold will be 90° with this. Now this face will join this face. This face will join this face at this point. Okay. Now this will be this figure. This side is showing this figure and this side is showing this one. So it is complete and the answer is A. First answer is A. How would you make a cardboard model of this numbered octahedron? Draw labeled sketches to show your solution. Okay. Question number 4. Question number 4. Now an octahedron is given to you. Octahedron. Now there are 4 faces which are in front of you and 4 at the back of. Same, if you just turn it, you'll see 4 figures. 1, 2, 3, 4 and 5, 6, 7 and 8. Okay, you just make them a little with the other color. 4. So these are hidden. 5, 6, 7, 8. Now the question is asked that how will you show these figures out of these? So it is very simple. You see these are 4 triangles here and 4 triangles at the back side. So there are 8 faces now, not 6. There are 8 faces. It is very simple to draw. You just draw 2 lines over here, 1, 2. Now this figure, when you will open it into the net, now this sort of figure will appear. This sort of figure will appear. And if you want to number it, now this is number 1, for example. This is number 1. Then this will be number 2. This will be number 2. You will match this point to this point. Okay. This is 3, 4, 5, 6, 7, 8. Okay. So this is complete figure. Now the last question is coming up, which is very easy. Now why we have done this practice so far? Why we have done this? Why? Why we have done it? Because we want to calculate the total surface area, TSA, or lateral surface area, TSA, which is called total surface area. Now, what is the total surface area? Total surface area, if I just pick up this book again, okay, now this is a cuboid. For this book, I have to find this area, the area of this cover page, the area of this cover page, area of the binding, which is also called the gutter space, area of the binding, area of the side, area of the front, area of this right side, and area of the base or bottom side. So when we add these 6 areas in this cuboid, we'll be naming it as total surface area. Now, why this is important? This is important because if I have to make it out of a cardboard, or I have to make some model or something like this, I have to know how much material has to be consumed. So this is why we are doing this practice. So let me proceed to question number last, which is question number 4, and then we'll be finishing this exercise today. Okay, now this is, I am going to draw again a rough sketch because for the need I take too much time. Now this is a rough sketch of figure. You have a book, so you will find it the right on the book. So the dimension is given. I am concerned with the dimension, not with the precision of the triangle. Okay. Now this side is 20 centimeters from here to here. This is 20 centimeters. Now this height is 2 from here to here. 20 centimeters is till here, okay, and till here. From here to here, 2 centimeters. This is 6 centimeters from here to here. This is 6 centimeters. Again, this is 2. This height is 2 and this width is also 2. This is 2 from here to here. This is 6 again. Okay, find the surface area of cuboid in centimeters square. Now, yes, what I told you, that we have to find the total surface area. Now you see that for each dimension there are 2 figures. Now this is one figure of the same dimension, this is one figure of the same dimension. So let me do it stepwise. First, now the larger triangles, the surface area of larger lateral rectangles. These are larger rectangles, 1, 2. Okay. Now the length is, L is for this, for 1 and 2. 1 and 2. 1 and 2. 1 plus 2. 1 plus 2. Okay. The length of it is 20. The breadth or width, you can say, W, is 6 centimeters. Centimeter. So since these are 2, so it will be the area is L into B of a rectangle. Area of rectangle is L into B. This is L, this is B. There are 2 figures of this side, so we will multiply it with 2. Okay, it will become this is not visible to you. Okay, I will do it here. So we have to find total surface area. So I am going to do it stepwise. Now first I will do the area of two rectangles which are 1 and 2. 1 and 2. All the dimensions are given to us. So it is now the area of rectangle. Area of rectangle is L into B. L into B. So there are two of same. So we will be doing it like this. Okay. Now keep the every answer with you. So 20 multiplied by this is 20 and this is 6 because this face is joining this face. So it will become 20 multiplied by 6. Okay, so keep every answer with you. This is 126, 2 times is 12, 120, 120 and 240. 240 centimeters square. Now this is done, this is done. Okay, now these two. So this is 2 multiplied by 20. Again the same 2 L into B. 2 L into B. This is 220. Length is 20, B is 2 now. 40 and 40 multiplied 2, 40 multiplied 2 is 80 centimeters square. The last 6 multiplied 2. Again there are 2, 1, 2, 6 multiplied 2. This is 12, 12 multiplied 2 is 24 centimeters. Just add them up. 240, 80 and 24. It is 4, 10, 4 and 344. It is 344 centimeters square. 344 centimeters square. Find the volume of cuboid in meters cube. Volume is always in cube. Whatsoever the unit is, it is in cube. So I have already found the area. In fact, in the volume what we have to do is we have to multiply all the 3 dimensions given to us. The 3 dimensions are given to us are 20 multiplied by 6 multiplied by 2. For volume, what will we do? We will add length into breadth into height. Or you can say it width. You can always write whatsoever. The LWH or LVH. So it is 20 given to you, it is 6 given to you and this is 2 given to you. So it will become 120 multiplied by 2. 120 multiplied by 2. 240 centimeter cube. Now this is in centimeter. We have to change it into meter cube. You see that this is a centimeter now. This is a centimeter. When this is centimeter and we have to go on higher side, we have to divide it. For example, for 100 centimeter, I want to make it in meters. So there are 100 centimeter in 1 meter. 100 centimeters in 1 meter. I divide it with 100. So when it will become, you see that 0, it will cross 1. So only 1 will have. So it is 1 is equal to 1 meter. 1 meter. 100 centimeters is equal to 1 meter. I just explained it to you. Now what we have is 240 centimeter cube. There are 3 dimensions. So for 3 dimensions, we will multiply it with 100 for 3 times. Okay, for 3 times. So the answer of our, you just make this 0, cut this 0 here. So this is what, how many zeros are left? 1, 2, 3, 4, 5. 5 zeros, 24 divided by 5 zeros. 1, 2, 3, 4, 5. Now, my dear students, see that this 0 is written upon 2, 4, and this is 2, and rest of 3 zeros are spare. So just write these 3 zeros over here, and for 1 drop, put a point over here and put a 0. Now this is your answer in meter cube. In meter cube. So my dear students, this has been completed. The lecture of exercise number 7.5 has been completed. So I'll work out quickly that so it can read to you. So it's time to say you goodbye. Allah Hafiz.